So these are some random questions from random sections of work. We'll start off today with some random questions from random sections of work. And let's start off with the first one. Okay, so question one. I want you to solve for x for this one. Solve for x. If you've got 3x plus 4 is equal to 9, 2x minus 3. Okay, question 2. If I've got y is equal to 3x plus 4, see if you can draw this. Okay, draw this line. Do whatever question you can. These are just random questions from random sections of work at the moment. Welcome, Aiden. Let me know what you're currently doing in school as well. And then the next question, I got 2 multiplied by 3/4. No calculators on this one. Minus 5 4/7. Slightly tricky question here. Divided by 3/4. No calculators allowed for this one here. Okay, you guys did graphs this week. Okay, cool. So no calculators allowed for this one. And then question 4. Yes, for question 2, I want you to draw the graph for question 2. If you can, sketch it on a curve like that, showing the x-intercept and y-intercept. Okay. So we're going to draw this one here. Try and draw it. What do you do? Maybe even use a table. You could use a table method where you get x values, y values, and then plot it. Get a random amount of those. Welcome everybody. We're doing random questions just to start off today. Some graphs, a little bit of algebra. Yeah, so if you can't send your graph, don't worry. Just try it on your side and then you can compare it to mine to see if it's right once I'm done here. And then question 4, if I've got 25.5, 44.2, and 33.3, I want you to give me what is the range of these values and what is the mean of these values as well, and what is the median of these values. Okay, quick random questions to start off today. As and when anyone joins in as well. All right. So I'm just gonna write you a quick random questions. Just like a test, just like an exam. It's almost like they ask you questions from everywhere. Something similar to this. Okay, quick random question. Try any one of these from here. Okay, so, and try all of them actually. Try all of them from here. Give it a go. All right, the first question over here, I got 3 bracket x plus 4 equals 9 bracket 2x minus 3. Now 3 multiplies into x to get you 3x. 3 multiplied by 4 is 12. That equals 9 times 2x is 18x. 9 times negative 3 is negative 27. If I bring all my x's onto the left-hand side, I have to change the sign from the plus in this case into minus 18x if I move it. And if I move the 12 to the other side, it becomes negative 12. 3 minus 18 is negative 15x. Negative 12 minus 27 is negative 29. Divide both sides by negative 15. And that will give you 29 over 15. You can leave it like that. Okay, so that's going to cancel out. Negative divided by negative is a positive. Your final answer is 29 over 15. So therefore, x is equal to 29 divided by 15. We can't divide it perfectly in there. We can leave it like that as a fraction. We can also write it as a mixed number, 1 and 14 over 15. All right, we're trying not to use a calculator at all during this process because we want to show all the working. And we're assuming that we don't have a calculator in a test. So if you don't have a calculator in a test, then that's what you gotta do. Right? Write it as a fraction, proper, improper, or mixed number. Okay. Question 2, they ask us to draw this. So if I use a table and I provide some values, let's say 0. If I put 0 in here, 0 times 3 is 0, and 0 plus 4 will get me 4. If I put another value like 1, 1 times 3 is 3 plus 4 gets me 7, and if I put another one, 2, 2 times 3 is 6 plus 4 gets me 10. What I have over here now is an ordered pair, set of coordinates, 0, 4, 1, 7, and 2, 10. And now I've got to look into my ability to plot. If I can plot this, then I'm done. Now, how do I choose these numbers? I mean, I could choose any 3 values of x. I started with 0 because 0 would be easy to find. We've got 0 and 4, right? So my y value is going to go up for, I've got to go up for 10. So your graph will be maybe different if you chose different x values. But it should look similar to this. So 0, 4, if this is 5, 0 and 4 should be over there. Okay, so I'm just going to 5 a little smaller. And then right at the bottom there is 4. So that point over there is 0, 4, just there. Then you got 1 and 7. All right, so I'm going to put 1 over here, 2 over here, and 3 over here. So 1 and 7, 6, 7, 8, 9. So let's say 7 is over here. So 1 and 7, let's make a dot over here. Then you got 2 and 10. 2 and 10 is over here. Okay, so that becomes a straight line, which we connect all the way through like that. Okay, if your line looks like that, well done. Let's go to the next one now. At the bottom here, we've got a complicated fraction. You're not allowed to use a calculator. What I'm going to do firstly, I am going to convert these two into improper fractions. All right, so step 1, I'm going to get improper fractions for this. Step 2, in the brackets, obviously, I'm just going to put a bracket around it because we're going to do that. And I'm going to find the lowest common denominator. And then because I'm dividing by a fraction, I'm going to use the tip and times method. All right, so tip over in times. Now, I don't have much space to work here, so tip and times, I'm going to just write there, tip and times over here. So let's say I just make this a little smaller so I can get some space. Maybe just a little smaller. Here we go. Hopefully that's enough space to do this question. Maybe not. I'll probably continue on this side here. So I'll draw a line over here and continue on this side here. So this is no calculators, right? So if you use a calculator, then it's pointless, right? You have to try it without a calculator. So here we go. I got a fraction here, first part here, fraction. I'm going to keep the 3 over 4 at the bottom. And I'm simply going to rewrite each of these, step 1, into improper fractions. 3 times 4 is 12 plus 1 is 13 over 4. 5 times 7 is 35. 35 plus 4 is 39. So 39 over 7. Now I don't have a calculator, so my answer can't even be in a decimal. It'll be in fraction form. So I got 3 over 4. The next thing I see is a common denominator of 28 at the top. And that's what I want to still sort out. I'm still in the bracket. I still need to sort that bracket out there. So from this here, we're looking at 7 times 13 is 70 plus 21. 70 plus 21 is 91, so it'll be 91. Minus 4 times 39 is like 4 times 9 is 36. 4 times 30 is 120. 120 plus 136 is 156. So 156, all divided by 4 times 7, which is 28. Just to double check this, 7 times 13, how did I do that so fast? 7 times 10, 7 times 3. 7 times 10 is 70, 7 times 3 is 21. 21 and 70, 91. That's how I got 91 there. And now I'm multiplying by 2. I'm still going to leave the 3/4 at the bottom there. Now, if you're not allowed to use a calculator, that means that in a test situation, they actually want to see these steps over there, right? So 2 can go into 28 14 times, so I can cancel out the 2. And 91 minus 156, just imagine, I don't have a calculator, right? So what is 91 minus 56? It's actually 156 minus 91 in reverse, right? So if I take 156 minus 91, I'll end up with a negative value. So if you have some working out paper somewhere, let's just work it out over here. So 156 minus 91, 6 minus 1 is 5, 5 minus 9 you can't, you borrow from 0, 15 minus 9 is 6, so 65, but it's the other way around, so it'll be negative 65 over 14. Now watch the next part. I'm done with the LCD, I'm done with the improper, now I'm going to do the tipping times. I'm going to take this fraction over here, all right, and remember this fraction, by the way, is negative 65, which I just calculated, remember it's the opposite sign, over 14, divided by 3 over 4. A fraction divided by a fraction. Tipping times show this part now. So the next part now, I take negative 65 over 14, and I have to multiply, that's where times comes in, and tip over the bottom fraction. So it becomes 4 over 3. Really complicated question, right? Now I can divide this by 2, and I can divide this by 2 to get 7. I'm going to multiply the top. 265 is negative 130. And 7 times 3 is 21. Now here's something else now. We have to simplify this. Can we simplify this further? Yes or no? If I can divide this by 3, no. I can divide this by 7. 7 goes into 13 once, remaining 6, no. So I'll probably leave it like this, and then maybe write it into a mixed number or not. Now 21 times 6 is 126, right? So this can go into there 6 times, and the remainder is 4 over 21, which I cannot simplify further. So either one of these would be preferable. Lots of working out there in a small space of time. You're going to use your LCDs, accuracy, etc. And it's a very good skill to have. Okay, let's go to question 4. Range. Range is the highest minus the lowest. The highest number is 44.2 minus the lowest number is 25.5. Again, under the assumption you don't have a calculator. So what do you do if you don't have a calculator for this? Again, it's a little bit of working out somewhere. Maybe if I can write it here at the bottom. Take 44.2 and just put 25.5 below. 2 minus 5 you can't, so you borrow, it becomes 3. 12 minus 5 is 7. 3 minus 5 you can't, you borrow 3, it becomes 13 minus 5, which is 8, 3 minus 2 is 1. So what you end up with 18.7, 18.7 positive value. The mean, you have to add it up and divide it by the total. This can get a little tricky without a calculator, right? So 25 plus is like ICAS. No, ICAS, no calculator. So imagine you had something like this, right? So 25.5, I have to now plus 44.2 plus 33.3 and divide all of it by 3. Again, let's do a quick calculation at the bottom. So we go 25.5, 44.2, and 33.3, and we're adding all of it up. 5 plus 2 is 7 plus 3 is 10, put the 0, carry the 1. 1 plus 5 is 6 plus 4 is 10 plus 3 is 13, carry the 1. 1 plus 2 is 3, 4, 7, 7 plus 3 is 10. That's 103.0, or 103, right? So this is going to equal 103 over 3. I can divide that. I can use short division. I can use short division for that. I could take 3, divide it into 103 like that. 3 goes into 1, can't. 3 goes into 10. 3, remainder 1. 3 goes into 13. 3 times 4 is 12. So 4, and then remainder 1 out of 3. So this is the same as 34. I can write here at the bottom here. 34 and a third. Okay, whopping no calculator with speed, as far as possible, with accuracy. All right, and you can please check me because I can also make mistakes. So let me know. The next one, median. When you're doing the median, you have to arrange it from smallest to biggest. Very important, smallest to biggest first, and then you find the middle number. So this is the smallest. So if I swap these two around, so if I rewrite this from smallest to biggest, that's going to be that. This is going to be 33.3, and this is going to be 44.2, and I can see my median is 33.2. And we're done with that. All right, so how did you guys do with that? Do you understand all of them? And how many did you get right? And what do you think went wrong? Time, calculator. Did you use, if you used the calculator, don't worry, you probably might have been tempted to or just used it anyway, especially for the stats part. But from these 4 questions, which question do you think was the worst question for you? Whether you got it right or wrong. Just type in. All right, cool. Let's jump into today's lesson now. Today's lesson, what we're going to be doing is we're going to be covering some straight line equations. All right. So today we're going to be doing some straight line equations. And we're going to be looking at the concept of y equals mx plus c. All right, straight line equations. How many of you heard of straight line equations? Yeah? And y equals mx plus c. Have you heard of that? Or mx plus d, some people say, or ax plus c, or ax plus q. Whatever, some number x plus some number, basically. All right, so the foundation of the straight line graph is that for every line, you have a y-intercept and a gradient. You have a y-intercept and a gradient. They call it a y-intercept because it is where you cut the y-axis. That's the y-intercept. And then you have the gradient. The gradient is if I start from the y-intercept and I travel towards the right to a certain point, horizontally, parallel to the x-axis, and I go up vertically parallel to the y-axis, such that this is 90 degrees, we take this value, which is known as your rise, and we take this value, which is known as your run, from there to there, distance from A to B, let's say, and then from B to C, and we take rise divided by run, the value of rising divided by the value of running, starting at the y-intercept, which is going to be BC over AB. We call that the gradient. All right, and we can do this for several different kind of straight lines. So that's what that is. So looking at the equation now, there's one thing you can remember. Now remember, this can be any letter. This can be C or whatever. This letter over here is that. It's your y-intercept, which means that that letter is actually that value on the y-axis. So for example, if I had y equals 2x plus 5, then d will equal 5. So this will go through the number 5. Okay? So keep that in mind. That number that's not next to x, that is alone, that number is your y-intercept and nothing else. Then you got the concept of rise over run, which is how far right you can go, how far left you can go, etc., depending on where you start. In this case here, if I'm traveling right, we call it run. Okay, we call it run. And when you're traveling right, it's actually a positive value. And then when you're traveling upwards, we call it rise, because from there you're going upwards and you rise. But sometimes you go down as well. We still call it rise. This is positive. But if I had to go backwards, then it would be negative in some way or the other. And we'll probably see that at some point through today's lesson. So let's go through an example of using table methods to plot the graph using substitution and then drawing an equation. Okay, let's go to a random equation. I got the random equation. Y is equal to, let me make it a little bigger. Random equation, y is equal to 3x plus 2. I want to develop a table of values of x and y values for this. Okay, so I'm going to develop a table of values of x and y values for this and provide some kind of x values and some kind of y values, etc. Okay, so there's going to be one there, and I'm just going to draw another one here. Oops. That's that, and then another one here, like that, and then here goes there. Okay, now I've got x values and I've got y values. I'm going to choose a random set of x values and y values. In particular, let's start from negative to positive. So negative 2, negative 1, 0, 1, 2, and 3. The first thing I'm going to do is substitute this value in here, multiply it by 3, and then plus 2. Let me say it again. Substitute it in here, multiply it by 3, and then take that answer and plus 2. And that will give me the respective y. There is a process of substitution involved in this, which looks like this. Y equals 3 times negative 2 plus 2. Now, 3 times negative 2 is negative 6, and negative 6 plus 2, this is going to be negative 6 plus 2. And negative 6 plus 2 is negative 4. That's what I would, if I substitute negative 2, I'll get negative 4. All right, so we got negative 4 for this one. If I substitute negative 1, I get negative 3 plus 2. Negative 3 plus 2 using integers is negative 1. If I put 0 in here, I get my y-intercept, my c value, my v value, whatever value you're going to call it, where it cuts the y-axis. If I put x equal to 0, I get my y-intercept. And that's a nice starting point, remember, when you have to find the gradient. 1 times 3 is 3 plus 2, which is 5. 2 times 3 is 6 plus 2, which is 8. 3 times 3 is 9 plus 2, which is 11. Now I've got a set of values, and I need to plot this now. Okay, so I'm going to minimize this whole thing, shrink it up, and we are going to draw this now. My vertical axis is known as my y-axis. My horizontal axis is known as my x-axis. My x-axis is my independent variable, and my y-axis is my dependent variable, because whatever value you put in for x, it's going to shoot out a corresponding y value. Right, so x is equal to -2 and -4. Let's grab those two values into a coordinate, -2, -4. And then let's grab those two, -1 and -1. That one, 0 and 2, etc. So we're going to plot each of these points on the graph. Because my y values is going up to 11, I'd like to have space on my graph with 11 written on it somewhere. So I'm gonna go up to 10 and all the way down. This is not accurate to -10 to keep it balanced. My x values are going from -2 to 3. So I'm gonna go from -1, -2, -3 up to +1, +2, +3, so that it's symmetrical. Now, sometimes, in most cases, you're given the graph paper and you just got to plot it. Okay, so that's -5 there. So here we go. Let's plot this one here. That's your x value. So we're going to go left 2 spaces, down 4. And negative x implies left. So we can go -2 and -4 down is going to end up roughly around here. That's the point. -2 to the left and -4 down. Don't forget how to plot. For those that are not sure about how to plot, I'll just quickly state this. You start at the origin, you're going to go 2 spaces to the left, because that's what that is. And then you go 4 spaces down. Now, obviously, the scale of the y-axis is smaller than the x-axis. So it looks smaller, but it's actually more. It's 4 spaces down. Let's go to the next value. -1 and -1, which is roughly -4, 3, 2, 1, which is very close there, so somewhere here. Then we got 0 and 2, 0 and 2, so this is going to go, let me just see if I can draw this, so 0 and 2, which is over there. Technically that point should be there. And 1 and 5 is there. Okay, and it will evolve into a straight line. So what I'm going to do is, I actually only need 2 points. If my graph is, even though I can't plot all the points, I'm gonna draw the graph and show you that if I have 2 points, I mean that's enough to get all the other points. If all the other points will lie on this line. So if I've got 2 points, I'm ready to draw the graph, pretty much. And there's my 2 points. So this point here, obviously is not accurate. It should be 1 and 5. 2 and 8, also not too accurate. And then 3 and 11, roughly around there. And -1. Getting my values and plotting my graph. That's a table of values, and that's how we would plot that. Now, there's another way to do this, because that way takes long. And you can see, I mean, it took quite a while. It took quite a while to do that. I mean, you draw up a table, then you plot the points. How much time do you actually have to do this? So let's actually fix this up. Let's say, okay, I don't have much time to do this. You know what? Show me another way. Show me another way that will go quicker to draw this line. So here's another way. This is called the dual intercept method. The dual intercept method says make x equal 0. All right. And then you get your y value, which is your y-intercept. So let's do that. Y equals 3, and x is now 0. 0 plus 2 is 2, so y equals 2. That gives me the coordinate x equals to 0 and y equals to 2. And I'm just simply going to plot it over there. Then make y equal 0. So let's make the y value equal to 0, which is on the left hand side, and let's find x. That becomes -2. If I move the 2 over, if I divide by 3 on both sides, I get x equals to -2 over 3, which is actually -0.67 to be precise. 2/3 of the way. I could also say -2/3. Okay, so this is going to be -2/3, and my y value is now 0. This is going to lie on the x-axis, somewhere on the x-axis, because the y value is 0. This one lies somewhere on the y-axis because the x value is 0. So y is basically the same as x equals to 0. And x is also the same as y equal to 0. There we go. We'll plot this now with -2 over 3 and 0. Where would I find that? Yes, so here's -1. -2/3 means -2/3 of the way. If I divide this into 3 parts, that's where -2/3 would be. Just over here. 2 points. That's all I need. I just need 2 points, and now I can connect these two straight away. And I know where it cuts my x-axis, I know where it cuts my y-axis. With a ruler, you combine these 2 points into your straight line over here. This is called the dual intercept method. Dual stands from the word 2 points. Intercepts mean 2 intercepts. Your y-intercept, where intercept is another word for cut. So intercept cuts the y-axis. And your x-intercept. Remember, to find your x-intercept, you make y equal 0. To find your y-intercept, you make x equal 0. So intercept over there, x-intercept. Now that you got that, you got make equal x equal 0, you got make y equal 0, and you now got your equation. You've done the dual intercept method. Done. All right, and that's called the dual intercept method. So if I have to give you maybe a set of values, and let's say if you can shoot out some coordinates for me, try this for a second. If I give you the equation y equals 2x plus 4, I want you to make x equal to 0 and get me the y value. And then I want you to make y equal to 0 and get me the x value. Type your answers in. Let's see if you can do it. Make x 0, find y, make y 0, find x. Type your answers as coordinates in. Type it in. Press pause. When you're done, press play. So in the first one, we make x equal to 0 and we solve for y. In the second one, we make y equal to 0 and we solve for x. The first one, we get 4. This one, we're now going to move 4 over. It'll become -4. And that's equal to 2x. We then divide both sides by 2. And that becomes canceling out. We want to get x on its own. -4 divided by 2 is -2. So this is going to be -2. All right. Now, once you have those two values, you are capable of drawing the graph. Okay? So that means you can draw this and you can sketch it by plotting 0, 4 and -2, 0. Why don't you go ahead and try and plot it? Try and plot the graph. I'll give you a second. Draw your y-axis, draw your x-axis, and plot the 2 points and connect it with a ruler. On your page, I won't be able to see it, but when you're done, type done. Most of you are done. Let's go through it now. So the first thing here is you draw a straight line, right? Down, which is your vertical axis, and you draw horizontal line. And you have your x over here, and you've got your y over here. And from this now, you have your y-intercept, which is 4. So 1, 2, 3, 4. That's your y-intercept. Make a dot. -2 and 0, 1, 2, Negative 2 would be around here, and now connect it with a ruler. And then once you connect it with the ruler, it would go through both the points. Put an arrow on both sides of your line to indicate that the line is continuity. So have these two arrows on either side. It's pretty important because the line doesn't stop somewhere in particular. So well done, you just drew a straight line. All right, you just drew a straight line. Cool. So negative 2 is definitely on the left-hand side. Remember, if it was on the right-hand side, negative 2 would become positive 2. And this coordinate over here is 2, 0. This coordinate over here is negative 2, 0. Okay. Try the next one. The next one is going to have a little bit of a negative in it. And this time, let's pick up the pace. Okay, let's pick up the pace here. So let's see. I'm going to give you the equation. Now, the equation is y equals 4x minus 2. It's got a negative y-intercept. I want you to get me the two coordinates first. So 0, get me the y-coordinate. Make y0, get me the x-coordinate. And then plot it in one go. Or try. I'll give you 1 minute. Should be enough time, hopefully. Let's see. All right. Did you get for this one here, negative 2? And did you get for this one over here, it's a bit tricky, this one, half? Right. So when you make y equal to 0, you get 4x minus 2. Moving the 2 over becomes positive. Dividing both sides by 4 gets you 2 divided by 4 is half. For the next one, making y equal to 0, x equal to 0, you're going to make 4 times 0 minus 2, which is 0 minus 2, which is just minus 2. Yeah? Cool. Then you plot it now. Take a second and try to plot it. Alrighty. Did your graph look something like this? So over here, I've got to go down by 2. Start at the center and go down to negative 2 on the y. Make a dot. Go right by a half. So a half will be maybe over here, let's say, if this was 1. There's the 2 dots, and now draw a straight line connecting the 2. Don't forget to label your y-axis and your x-axis just as a normal routine. Well done if you got it. Excellent if your graph looks like this. We're moving on to the negative gradient now. So let's, again, now you should be like really good at this. So y equals to this, but this time we got a negative gradient. So y equals to negative 3x plus 6. Step 1, get me the y-intercept and the x-intercept, and then draw it. Let me know when you're done now. Just type done. Press pause and then give it a go. Alright, so the first thing here we're going to do is make x equal to 0 and y becomes 6. 0 times anything is 0 plus 6 is 6. When I make y equal to 0, I get negative 3x plus 6. If I move this over, it becomes positive 3x. Now 3 times what gives you 6? 2, right? 3 times 2 is 6. This is going to be 2 and 0. Now that I have those 2 points, I'm pretty much done now. It's just about plotting it. And plotting is not too bad once you get used to it, right? Actually quite simple. So 0, 6, don't get confused which one goes where. 0, 6, this is going to go up. So 1, 2, 3, 4, 5, 6 units up. And 2, 1, 2 is going to be my x-axis, 6 is my y-axis, and then I'm done. What do you notice about this graph? It's different. This graph is sloping. It's descending, it's sloping towards the left. This graph is y equals negative 2x plus 6, and so the slope, which is equal to negative 2, which is another word for gradient, is negative. So if you have negative gradients, it goes this way. If you have positive gradients, it goes that way. Okay. And that's how we work that one out there. So well done on plotting those and getting them done. You can now find x-intercepts, y-intercepts, and you know how to draw graphs, which is excellent. We're going to now look at the concept of gradient in particular. All right. Type ready if you're ready to move on. All right, cool. Now, if I've got two values over here, I've got x1 and y1, and I've got x2 and I've got y2, I can put this in what is known as a gradient equation, which is the slope, right? Same thing. The gradient equation is given by taking the y2 minus y1 divided by x2 minus x1. And notice in particular, we got y2 over here, which is over there, right? And we've got y1, which is over there. Then we've got x2 at the bottom, and we've got x1 at the bottom. We've got the y's at the top and the x's at the bottom. Okay? Let's test this with specific coordinates. So now, let's suppose I've got the coordinates 2, 3, and 5, 7. The gradient is going to be calculated by taking y2 minus y1, so that's 7 minus 3, over x2 minus x1, those two, which is going to be those two, 5 minus 2. 7 minus 3 is 4, and 5 minus 2 is 3, and that's 1 and a third. And that's the gradient, either 4 over 3 or 1 and a third. Not bad, right? Okay, let's change it up a bit. Let's take these values and let's add a negative in there now. Negative 2, 4, 7, and 5. Remember, y2 minus y1. So it's 5 minus 1. I'm just going to call it m now because this is actually the value that goes in your straight line over there. That number there next to x. So m is going to equal 5 minus 4 over 7 minus 2, alarm bells, minus 2 is plus 2. That's 1. 7 plus 2 is 9. So the gradient for this is 1 over 9. Don't forget the double negatives. So when you have a negative, you'll end up with some positive at some point, but you have to be careful. Let's do another one now with, remember that m, right? From y equals to mx plus c. I got two coordinates, let's say 3 and 4, 5 and negative 7. Negative 7 minus 4 over 5 minus 3. That becomes negative 11 over 2. That's negative 5.5, negative 5.5. And that's the gradient. This gradient is going to go that way. This line is going to slope towards the left. That number is negative. Now let's add two negatives in here. Make it even more interesting. I got negative 1 and negative, now let's make it 5, and let's add a negative in this side here. So 3 and negative 9. Let's start with these two now. Negative, by the way, this is m equals to negative 9 minus 5. Negative 9 minus 5. That's a negative 9 minus a 5, which is actually negative 14. Not positive. 3 minus minus 1, 3 minus minus 1 is going to be plus 1. And that's 4, not 2. And I can simplify this to get negative 7 over 2. And this line is also going to be sloping this way because it's a negative gradient. Let's do another one, but this time I'm going to introduce three negatives, negative 3, negative 4, 7, and negative 10. Let's go. Negative 10 minus 4. Keep the bracket there. Keep the brackets. The brackets is your lifesaver. 7 minus 3. Going back this way, that's going to be equal to negative 10 plus 4. And this is 7 plus 3. And that comes to negative 6 over 10, which is basically negative 3 over 5. Negative 3 over 5. Again, negative gradient. Lastly, let's do negatives all around. Let's go negatives all around, okay? Negative 3, negative 4, negative 9, negative 12. There we go. Negative 12, negative 12 minus 4 divided by negative 9 minus 3. That becomes negative 12 plus 4. And that becomes negative 9 plus 3. That's negative 8. And that's negative 6. That divides into a positive 4 over 3. This line is actually sloping positively. Can you do this? If I give you two coordinates, can you do this? Yeah? Alright. I am going to give you a challenge. I'm going to put two coordinates in this block. I'm going to put two coordinates in this block. And I'm going to put two coordinates in this block, and you're going to get me three gradients as fast as you can using the substitution of it. Just type your answers in. This is going to be question A, this is going to be question B, and this is going to be question C. The coordinates are going to start with two positive coordinates, then it's going to have two negatives, and then it's going to have three negatives, or one negative and two negatives. Let's see. All right, get ready, get your pen and paper ready, and let's see if you can do this. We've got 3, 7, and 5, 8, negative 2, 1, 3, and 5, negative 3, 4, 5, and negative 9. Write your answer in a simplified fraction form. When you're done, just the answer. Shoot it out there. We'll check the answer right at the end, but just send it anyway. Press pause, try it. All right, let's go through the first one. Right, here we go. 8 minus 7 over 5 minus 3. That's going to give you 1 over 2. Next one, 5 minus 1 over 3 minus bracket minus 2. That comes 4. 3 plus 2 is 5. Next one, start from the y's. Negative 9 minus 4 over 5 minus 3, be careful, negative 13. 5 plus 3 is 8. Negative 13 over 8, and we're done. Well done to some of you who got some really good answers there. Well done. Excellent job. Okay, cool. So, you know what a y-intercept is, and you know what a gradient is? So the first thing we're going to do now is the first Kahoot of 3 Kahoots, but we probably won't have time to do all of them. So go into the chat now, click on the Kahoot, join the Kahoot. There are 19 players that you're playing against. Let's see if you can get to the top and join the top. Click on the Kahoot and begin 25 questions coming through on gradients and y-intercepts. Good luck. When you start at the Kahoot, you can just type start or I'm in. All right. Click on the link. Give it a go.